In this video, we're going to talk about factoring, specifically the technique of factoring out the greatest common factor. Now, before we jump into that, we need to recall multiplying. So let's say I had 5x and I multiplied it by 2x plus 3. Remember that we distribute into the parentheses. 5 times 2 would be 10, and x times x would be x squared. And then when I take 5x times 3, well, 5 times 3 is 15, and the x would get multiplied to that. So my product would be 10x squared plus 15x. Now, what we're going to be doing with the greatest common factor is we're going to be doing the reverse of distribution. Instead of multiplying in, we're going to be thinking about what can I divide out of both terms. So let's look at some examples of this. So let's say I look at number 1. I have 3x squared plus 9x. I want to think about what is the greatest common factor. What is the biggest number that goes into 3 and 9? Well, 3 is the biggest number that goes into 3 and 9. Then I want to think about what's the greatest number of x's that I can divide out of both. Now, when I divide it out of both, the number of x's has to be shared in both. What I mean by that is it has to be able to go in. For example, if I tried to take out x squared right now, well, x squared divided by x squared would leave me with none. But can I divide x by x squared? No. Okay, because there's only 1 here, so that won't work. Okay, so when I do this, I take out the greatest number, which is 3, and then I look for the amount of x's that I can take out of both. Well, they each have at least 1 x. This has x to the first, this one has 2, so they both have at least 1. So I pull 1 x out. Then inside the parentheses, I leave what's left over when I divide this out. Well, 3 divided by 3 is 1. If I take x squared and I divide by an x, or I pull an x off, I'm left with just 1x. Then if I take 9 divided by 3, I get 3. If I pull the x off, I'm left with no x's. Okay, so my answer is 3x times 1x plus 3. Now, normally in math, we don't write the 1 in front, so normally our answer would look 3x times x plus 3. Okay, this would be the factored form of this binomial. Now, if I wanted to check my work, remember I could just redistribute and I should get this back. So if I take 3x times x plus 3 and I distribute the 3x back in, I should get what I had to start with. Well, 3 times 1 is 3. X times x is x squared. 3x times 3 is 9x. It matches, so this is correct. All right, let's look at another example of this. So in number 2, I have 8x to the fourth minus 20x squared. Now, once again, I'm thinking about what's the biggest number that divides into both. Well, in this case, it's 4. Then I think about what's the greatest number of x's that they both share in common. Well, they both have at least 2, so I can pull out x squared. Then inside the parentheses, I write down what's left over. Well, 8 divided by 4 is 2. If I take x squared off, I'm left with x squared. Negative 20 divided by 4 is negative 5, and if I take the x squared off, there's no x's left. This would be my factored form. If I wanted to check it, once again, I could just redistribute and I should get this back. 4 times 2 is 8. X squared times x squared is x to the fourth. 4 times negative 5 is negative 20 times the x squared. All right, one last problem here. Here you'll notice we have multiple variables. I think this will help us understand how the greatest common factor works. So once again, it's the same process. I look at the numbers and I ask myself, what's the biggest number that goes into both 15 and 10? Well, in this case, it's 5. Then I look at each base, each variable individually. So I have x to the third and x to the seventh. How many do they have in common? Well, they both have 3 in common. Then I have y to the first and y to the fourth. How many do they share in common? Just 1. And then I have z squared and the z. How many do they have in common? Well, just 1 again. Then inside the parentheses, I write down what's left over. 15 divided by 5 is 3. If I take the x to the third out, I don't have any left. If I take the y out, I don't have any left. If I take one z off, I'm left with one z on. Then I move to my second term. If I take negative 10 divided by 5, I'm left with negative 2. If I add x to the 7th and I divide out 3, I'm pulling 3 off, I'm left with 4. If I pull a y off, I'm left with 3. And if I pull the z off, I don't have any z's left over. This would be the factored form.